This is the final video concerning this problem, and we talked about A already, we talked about B, so now we're going to finish the problem by talking about C, and this one's special compared to the other two, because this one is linked in a chain, and anytime a molecule is linked in a chain, we consider this molecule to be, they use this special word, they call it cyclic, and it just means the molecules interlinked in a ring. And we can see that here, and I have the two chiral carbons in these stars right here, and of course you can see the alkyl halide and the amine. So we're going to focus in this video on C, and this C molecule, this cyclic molecule, we're going to find the chirality of this molecule, and we're going to draw a special type of isomer of this molecule called a constitutional isomer. Right, and we're going to make the amine, we're going to make that green. And the other group, the alkyl halide, we're going to make it purple. And of course, we have two more things here, and we're just going to keep these things in black. Well, we'll make them the same color. There is a hydrogen right here, and there is another hydrogen. That hydrogen is right here. And so now, since we have our molecule assembled here, we can show where the chiral carbons are. Here's a chiral carbon, and there's a chiral carbon. So what we'll do is we'll zoom into each chiral carbon. Let's zoom in. If we zoom in, what does it look like? Well, it looks like this if we were to zoom in. There's our iodide, and then our hydrogen is in the back still. And of course, you know, we have to rank priority here. And the thing is, here, we have the iodide and we have the hydrogen here. The hydrogen on the dashed line and the iodide on the shaded line. The shaded line is coming towards us. The dashed line is going away from us. Now, what we have to do now is look at this carbon here and this carbon here that are in the ring. This here is a CH2. That there is a CH2. So they're both the same, but we know that they're both carbon and they both have an atomic number of 6. And the hydrogen in the back has an atomic number of 1. And this iodide, it has an atomic number of, like, it's very high. I know it's more than 40. It's definitely more than 40. So whatever it is, it's going to be more than 40. So we can see that the iodide is definitely going to have the highest atomic number. So it's going to be number 1 in our ranking of priorities. So this will be number 1. The hydrogen will be number 4 because it has an atomic number of 1. The two carbons, we have to look at these in more detail because the two carbons, they both have the same atomic number. And since they both have the same atomic number, we have to go further on in the molecule until we see, oh, well, you know what though? To be honest with you, I actually made a mistake here. And the mistake I made was I need to cross that one out. Carbon. This is a carbon that's connected to a nitrogen. A nitrogen and another carbon. And it's connected also to a hydrogen. So, this carbon here is connected to 2 hydrogens and a carbon. So in this example, looking at those atoms there, the carbon and the 2 hydrogens, and the hydrogen, the carbon, and the nitrogen. And we can see that this is more important at the 2. So this will be number 2, and this will be number 3. Now, so since we've ranked the priorities, the iodide is number 1, the hydrogen is number 4. Between these three, this is going to be 2 because all these atomic numbers are higher than these. So this is going to be 2, that's going to be 3. Oh, sorry. So what we're going to do is clean it up. Let's clean it up. When we clean it up, it's going to look like this. We'll just not worry about the colors anymore. So this will be number 1. That'll be 4. That'll be 3. And this will be 2. And the 4 is, okay, now anytime we do this, the 4 always has to be oriented in the back. And what I mean by in the back, it has to be on the dashed line. The 4 has to be. And if it's not, we have to use a certain technique to make the 4 oriented in the dashed direction to to find the configuration of this chiral carbon. Now, if we go from 1 to 2, from 2 to 3, and from 3 to 1, that looks like S to me, or that looks like a S configuration because it's going counterclockwise. So this carbon here is going to be counterclockwise, so we're going to write S right there. We're going to do the same thing for this carbon. We're going to zoom in for it. Going to zoom in. If we zoomed in, we get a structure that looks like this, and I'll write it over here. Looks like this, where we have that. The hydrogen is coming like that. The nitrogen is in the back. So with this, on this one, we're actually going to have to use the technique where we have to rotate the bottom. It's a very interesting technique that a student introduced to me once, and it works very well. So the hydrogen is to the right, the nitrogen is in the back, and on the bottom there, we got a carbon that's connected to iodide. A carbon and a hydrogen. And up top up there, we got, and this is the same iodide, the pink, the purple one, and the same hydrogen that's connected there. So, okay, so this one is, the one above though is CH, that's going to be a CH2C, and we can see that this iodide is definitely, the iodide carbon hydrogen is going to have a higher priority than 2 hydrogens and 1 carbon. Because of course, you know, since we have 2 carbons here, we can't rank the priority between 2 carbons because they have the same atomic number. So if we go to the next thing in line, we have to take consideration the hydrogen, the carbon, the iodide versus the carbon and the 2 hydrogens. And of course we can see iodide has a very high atomic number, so automatically we can see that this will be more important. So we can say that nitrogen will be number 1 because nitrogen has an atomic number higher than these 2 carbons in this hydrogen, which is going to be number 4 because it has an atomic number of 1, which is lower than these 2 carbons. So we got 1 and 4 because this is the highest and that's the lowest, and the ones that are in between, that's going to be 2, and that's going to be 3. This is going to be 2 because of the iodide in this group, really. Now, what we're going to do is go over here. Let's clean this group up. Let's clean it up. We clean it up from being so messy so we can see what the heck is going on. We have 4. We have 1. We have 2. We have 3. So we have all these things. So now we can use a technique for the first time that we haven't used yet. And what we're going to do is we have to know. Now notice this. If you have a tetrahedral structure, and what I mean is, you know, the tetrahedral structure has three spatial type of things associated with it. And what I mean is 3 things you can grab onto. And what I mean is, like, you can grab onto that 3, that 2, that 1, and that 4. If your hand was, if your hand could grab onto those, it could grab onto each one of those. So it's like a cross if you kind of think about it. So we're gonna grab onto the 3 in this technique in our mind. If we grab onto the 3 and we get a firm grasp on the 3, what you have on the bottom is a 2, a 1, and a 4. So what this means is we're only focused on the 4, the 1, and the 2 because the 3 never changes because it's on the top of the tetrahedral structure during our mental rotation. So the 4 has to be in the back for us to be able to rank the configuration or to get the correct RS configuration. So what I like to do is I just like to cross the 4 out here, and whatever number is in the back, I'll also cross that number out, and I just put the 4 in the back. Okay, now since I've finally placed the 4 in the back, we got some numbers that are floating around in limbo. Or what I mean is we don't know exactly where certain numbers go. So we got the 4 in the back right here, but up top we got 3 right there. And 3 can't move because 3 has to stay right there. The 4 can't move because the 4 has to be in the back. Notice that we only have 2 more numbers we have to take into consideration. The number 2 and the number 1, which previously was behind the 4. So what we're going to do is, since the 2 cannot be in this spot because the 2 has to move considering how it's on the bottom 3 numbers, we can't move it where the 4 is because the 4 has to be right there. It can't remain where it is because the 2 has to move, nor can it go to 3. Of course not, because 3 can't move. So the 2 has to be in that spot right there, just by right. So since we can see this, we can see that by a process of elimination, we only have one possible spot where to put the 1, and that's right there in that spot. So now we're going to clean one more time because it got messy again. So if we clean one more time, we get a thing that looks like this, where the 4 is in the back, the 2 is there, the 1 is there, and the 3 is on top. So, and it's starting to get kind of messy. So now what we're going to do is we're going to write our priorities in there, or we're going to do the counterclockwise, clockwise thing. So we go from 1 to 2, 2 to 3, we go from 3 to 1, and now we have this same thing. We have another S, because it goes counterclockwise. The arrows do. So this is going to be S up here. So we got 2 S's in this compound. So we ranked all our priorities, and we gave our compound SS and all these good things. But the last thing that we need to do is we need to take our compound and we need to make a constitutional isomer of this compound, or a structural isomer. And this is not going to be very complicated because actually a structural isomer, constitutional isomer, it's the easiest one to write.
Problem in the next video.